Okay, is that working for everyone? Hey. So let's just see if this is working. So if you give a thumbs up on that message, if you can see it and hear everything, that would be great. So if anyone can't hear, just say and we'll try and fix it. Just give it 1 more minute and just wait for some other people to come in, and then we'll get started. So if anyone had any issues connecting, just let me know, just post a message, because there was a typo before, but it should be changed now as well. Okay, right. So I think we'll get started then. So today's session is about misconfigurations. So the aim of Security Champions, as everyone knows, to teach developers how to hack, how to teach developers how to develop secure code, and to raise awareness of how small issues can spiral out into other issues, potentially compromising the entire environment. So today we are looking at a web app that's misconfigured. So we want to root the underlying infrastructure by exploiting vulnerabilities in the app. This app, I guess you could say it mimics an app maybe fresh out of dev. It's had no security testing, nothing else really put onto it. And there's limited functionality, and we can assume the developers have had very limited web app security training. So the application can be found here, which I sent out on Slack. So I said ignore the lack of HTTPS, it doesn't matter for this. So it looks like this. So it's just a standard app. This is the sort of thing we test, probably not this basic, but often we are given apps that don't have full functionality yet. So we do a sort of respective test on that. So this is what the app looks like. So the first thing we would do as an attacker is we want to know what the application is actually doing. We want to know what core features there are, what language it's written in, what it does, if there's any cool key functionality on it, anything that we can then look to exploit or adapt in a malicious way. So first thing we would do is we'd have a click around the app, we check out the site, see where all the buttons take us, generally get a better feel for the application and what it's doing. So normally the first half a day is spent looking around an app, trying to work out what's going on. So is there a contact form? Is there any file upload, anything like that? So yeah, so really it's just looking around and seeing what there is. So we can see most of the buttons are just taking us just to anchors on the page, just scrolling to them. And then there's an email button, but that's fairly boring. There's no contact form. We can look at putting anything nasty in. But then if we click this one, it actually takes us to a new page. And although there's nothing on here, it's quite interesting what it's doing in the background. So we can see here, just reiterating that bottom button to take you to the tools that's really the only bit of the only bit of technology that actually looks interesting for us. So let's see what it does. Ooh. Don't know why that rushed through. Okay, so when you click the button, you're taken to this URL, which is the IP address of the site, and then this view.php page equals tools.html. So we want to know really, like, what, if you guys have any ideas about what the software behind the scenes is actually doing, and what do you think the source code of view.php roughly looks like? Because this is the place where there could be a vulnerability due to the format of this. I mean, if you've read the slides already, you'll know. But otherwise, if everyone takes a minute to think, and then we can go through the source code after, and we can highlight where the potential vulnerability is. So if we go into it, the source code of the actual page looks like this here. So what we can assume is happening is the view.php file contains a function to display the contents of another file onto the screen. This is interesting as we actually control this parameter that the function's processing. And here's the source code. So it takes a page parameter out of the URL, which is up here, which we then specify. It then includes /var/www/ then appends the page parameter onto the end of it. So obviously this is bad because it's trusting user input that an attacker can put in, but there's no validation on what this input is, which results in this, the first vulnerability. So we know that application's taking the contents of another file and displaying them on the site. So instead of accessing tools.html, which is what the page is trying to load when you use that button, why don't we see if we can include another file from the file system instead? But we need to know what file system it's actually running, what operating system it's running. We need to know if it's running Windows or if it's running Linux or anything else. So an easy way to do it is to ping it. So most Windows versions will reply with a TTL of 32 to a ping. Most Linux systems will reply with a TTL of 64. So by pinging the actual web server address, it quickly shows us that the underlying infrastructure is most likely Linux. So we can do it from our attacking box, which is here. So the one that you should have SSH'd into. So we can then do ping, whatever the address was, so 3.8.128.225 without the HTTP. And what we should see is there's a TTL of 63, but that's only because there's one hop. So normally if there's no hop, it would be 64, but because there's a hop, it takes one off for every intermediary device. So say this was a TTL of 59 or 58, it's still safe to assume it's a Linux machine, just there's multiple things in the way. And then again, if it was 32, it's safe to say it's Windows, or 28 or 27, the same as that. So this is just an easy way to quickly enumerate what operating system is running. Of course, there's other ways to do it. We could try and get the application to error. There's loads of other things, look for specific files, but this is just an easy way we can identify. So we know it's running Linux because we had a TTL of 63. So we can attempt to now abuse the web app functionality to include the contents of a system file that we know is present on a Linux system. So what we can do is we can set the page parameter in the URL to be .. /etc/parsewd. So our complete URL now looks like you have the IP address, the view.php page, then you give the question mark as a parameter, question mark page, sorry, as a parameter, and then you give the page this string. This is your page parameter that is going into here. So you should be able to see if you've worked with Linux, that what these dot dot slashes is going to do is going to recurse back through the file system up to the top level, and then go to etc/password and display the contents on the page. So we can do it. So we can come up to here and we can go page equals dot dot slash dot dot slash dot dot slash dot dot slash. So it doesn't matter how many you do, because it will just keep going up to the top level directory again, as long as you do enough. So /etc/passwd, and then we can see we've included a local file into the web app that certainly wasn't intended. So the contents of etc password looks, where is it? So yeah, etc password, we choose this because every user has access to it on a Linux system. It also provides you a bit more information on the system, as it gives a list of users. So you can see you've got a root user, you've got a Zico user, you've got a MySQL server user. So we can start enumerating a bit more about the operating system from this as well. So this is a key file to use. This is normally what's used in a proof of concept. And so the dot dot slashes are to get to recurse out of this hard-coded directory back into the top level, and then we just specify a full path of etc password. Often on this sort of vulnerability, you might, if it doesn't work, you might have to include a null byte, which in URL encoding is %00. Often this then terminates the string at the end, because sometimes the web app will add some other junk to the end of it. So if you put a null byte in, it will just make sure it just goes to your specified string. But in this case, we don't need to put one on. It's just something else to be aware of. So as you can see, the output looks like that. So now what? So we know we can pull files from the operating system into the body of the web app. Assuming developers have at least ensured that the web app is running with the least level of privilege as possible, there isn't really too much else we can do here. We can attempt to keep enumerating more files in the system, but we're going to be blocked because of permissions, because we're only running, assumedly, we're only running as that low privilege, probably www-data user. So we want to move on a bit. So we found that vulnerability, but now we want to look at what else there is going on this app. So we assume it's pretty small. We don't think that there's that much more functionality on this page we found on this directory. So we want to brute force some extra directories in the hope of finding something else. So there's a lot of tools that do this, both using the command line and a GUI and everything else. The tool I'm going to use is Metasploit, because it's easy to use, it's open source, it's free, and it's really good. It's a really good hacking tool due to all the functionality it has. So if you go onto the hacking box and you type MSF console, you should then be greeted. It should then load up the Metasploit program. So we can see here just a bit of information. And what Metasploit is it's a tool that has a collection of other tools built into it. So there's active exploits, there's auxiliary scanning modules, loads of other stuff, loads of virus encoders and everything else cool like that. So it's a really good tool to use. But what we want it for is to do the scanning of the directories on this web app. So we use a module, we use an auxiliary scanning module. So we do use auxiliary, and you can auto-complete as well, which is nice. Scanner, HTTP, and the_scanner. So what this has done now is this has loaded this module into Metasploit that we can then use. So we can do a show info to show what it does. So you can see it's directory scanner, and these are all the variables you can give it. So it's taking this as a dictionary. So what it's doing is it's testing every single word in this dictionary against that IP address. So it's doing that IP address slash, and then a word in this to see if the directory exists. So we need to give it and our hosts, which is the target address range. We're not going through a proxy, so it doesn't matter. We only need one thread, and we're hitting port 80. So to configure this, we want to do set our hosts to the IP address of the site, which is 3.8.125.225. So that's now set. So if we do show options, we can see that's been set in here. And then we can simply click run. So you could, if you wanted to do this for a longer time, we could change this dictionary to have a vast amount of words in it. But for this, we're only looking for really common words and admin pages, for example. So if we run it, we find that it works, and it's given all these, it's found all these things out of its word list. So here, there's a 403, so we've got an unauthorized for that. This one, you can go to /CSS, but no one really cares. dbadmin, another unauthorized, images, JavaScript, and some views. So these aren't really good. As an attacker, this clearly sticks out. The fact that there's a dbadmin directory that we have access to from this 200OK HTTP response. So this is interesting, so I think we should look at it. It'll be the first thing I would do on a test is go and have a look at that. So there's the scanner, if you want to do it again. So it'd be use auxiliary scanner HTTP _scanner. Run it, and then as you can see there, it's highlighted that this is a key piece of interest that we want to look at further. So let's go to it. So we keep that IP address, and then we go to dbadmin. And you can see there's a folder structure here. So as I was saying earlier, you can get the page to tell you what it is. You don't just have to ping it. Like sometimes it'll just give you it. So you can see it's running Ubuntu. So our assumption was correct. Then there's a page here, or file here, sorry, test_db.php. So we click that. And now we're greeted with an admin panel, presumably for the back end of the site. So we can see that the software in use is PHP Lite Admin, version 1.9.3. So yeah, this is lesson 1 of every login page ever created, ever. Is the first person to try on any admin page should either always be admin or password. And failing this, simply Googling for this software and version and searching default password often works. And also, if there's no rate limiting on this or no brute force protection, we could also script something up to keep attempting to log into this. But then that's a very noisy attack. You're more likely to get picked up. Anyway, so we're going to log in. We can find that the password of admin actually works, which happens all the time. And now we're in. So this is what it is. We can create new databases. We can add users, etc., etc. So something that wasn't included in the slides that I forgot to mention is that we can actually view this test user database that was on there already. And we can view some extra pieces here, some hashes that look like MD5 hashes. We could try and crack these. I'm going to tell you now they can't be cracked. If you're on a test, one of the first things you would do is you'd enumerate all the database structures, and then you would try and crack these hashes to attempt to get passwords you could then use. But we're going to say we can't. We're going to say they don't work, they don't crack, they're too complex. So we're going to go forwards. So the next thing really I would do is look at this version, say, well, is there any already public vulnerabilities for this version of PHP Lite Admin? So if we have a look online, there's multiple places with write-ups for this vulnerable version of this software. For example, if you go onto ExploitDB, if you follow this link, you can actually read the original release for it, talking about the vulnerability, how to exploit it. So if we follow that, we can actually see actually, well, it's in the next page anyway. This is basically what that exploit DB page says. So if you create a database with a .php extension, that any PHP code you put into it will actually be rendered in that site if you can access that PHP page. So normally you shouldn't be able to create a SQLite database with a .php extension, but for some reason the developers have screwed it up and you can. So the first thing we can do is, if we follow these instructions in the slides, first thing we do is create a new database with a .php extension. So you can do test.php, create. So now we can see up here we've got in /user databases /test.php, we have a new database created. So now we want to create a new table in the database. We're following along with this vulnerability thing that was published online, so we can call this test again. We only need one field. So this is the fun bit, because we have to change the type to text, and anything now we put in here will be executed as, well, it will be put onto the screen, and if it's containing PHP code, we then have a code injection vulnerability that allows us to do other things on the system. So for example, if we were to copy and paste this in, what it would do is it would add PHP code, so whenever we access this user databases /test.php, we can append a CMD parameter onto it, and what then this will do is this will then run a system command with this CMD parameter. So it should all make a bit more sense in a minute once we do it. I am going to copy that out because it's a lot easier than typing it out. So if we now copy this into here, we can see we've put all that PHP code in there and we create it. So that means that now if anyone has access to this test.php or /user /databases /test.php, if they can get to that in a browser, then this PHP web shell effectively is going to be there. So, like we said before, the PHP page now takes a command parameter and executes this as a command due to a code injection vulnerability in the PHP Lite admin software. So this is good, but we have no way of actually accessing this PHP code unless we think about what just happened 10 minutes ago. So we can remember that previously that file inclusion bug allowed us to include any file on the server into the web page, providing we have the permissions for it. So you should be able to see how we can use that previous issue to then pull this page that we've just created into it. So we can see that using the previous local file inclusion bug, we can actually now call our new PHP file to have a command shell access onto the host. So what we do is the same URL before, view.php page. We still then recursing through the file system, and then we now give it the full path of user databases test.php, which is here, and then we give it the and command equals, and then this is where your command goes. So if we do that, we can do so page equals // So user databases test.php so we can see it's not pretty, but we can see what's happened is this command.ls, the output has actually been put in here. So this is the files in your current directory that's actually being displayed on the screen. So if we did the same for whoami, another Linux command, we could see that in here, due to that code injection vulnerability, we can actually use the PHP code injection to get command shell access onto this host, which is cool. So we can do loads of things here. We can just basically, as we're in front of a terminal on the machine, but it's not very efficient. We want to improve on this shell. So what we can do, so if you were on the previous sessions, what we can do is actually get the web app to execute a reverse shell back to our machine that we can then interact with better. So PHP has it. There's a way you can get reverse shells back using PHP. So we can do that. So this command it basically opens a socket to this is the IP of our listening machine, a port, and then it executes an interactive shell that then gets sent back to this port. If people are doing this on Slack, we can run the same command, we just need to change the port, because if someone else is listening on your port, it's not going to work. So if everyone just picks a unique port between 0 and 65,000, that'd be great. Yeah. Can you put that in, Sean?
Yeah.
What, the script?
Yeah.
Or the fact you need to... Yeah, so everyone just needs to pick a different number.
You mean the PHP reverse shell?
Oh, okay.
Yeah.
Okay, that's fine.
Okay. Yeah.
So basically, because this payload is going to go into our URL, we have to do something called URL encoding, so the browser understands it. So this is what it looks like URL encoded. We can do it online. We can just paste in a string and search URL encoding, and it will do it for you. So this is what our string looks like. So let me put this into Slack for everyone. Ooh. Yeah, I'll just paste it in quickly. So people will have to change, wherever it is, this piece here. So that is the piece you'll have to change because that's the specifying the port. And if everyone listens on the same port, it just doesn't work. You just get an error for someone else already listening on it. So people just post what port they're going to use, and then just modify this, and then just keep it copied and pasted. I'm just going to quit Slack. So this is the payload we need. So what this will do then, like I said, it will send a shell back to a machine, but we need a way of catching this shell. So if you remember from previous sessions, we need a listener somewhere to listen for this shell. So a tool we could use is Netcat, or we could use Metasploit or anything else that has this functionality. So we're going to use Netcat on our attacking machine to start a listener on the port we've selected. So to get out of Metasploit, you can just do exit because we don't need it anymore. And now we want to do Netcat, so I'll pick 60,000. So we do netcat-nvlp, which now opens a port on port 60,000, waiting for a connection from somewhere. So now we can put this command in to our browser. Ooh. So into this parameter here, into the CMD parameter where we put in all the LSs and everything else, we now want to put in our URL encoded string, which is basically going to execute this PHP code on that server. So this is the port parameter. So we change that to 60.123. And now what that is going to do is hopefully send us a shell. So we can see here that we've now got a reverse shell on that web server that we can see here. So connection there from this random port is given. So we now have a more interactive shell. So we can do ls, id, who am I, all the stuff we were doing before in the web app. Up here, we can now do in an interactive session, which is miles easier and it's just a million times better. But we can improve on this still. we want to make our shell look pretty. Makes it a lot easier, opens up a bit more functionality we need as well, because it's all right, but it's not quite what we want. So in Python, it's an easy way to get a proper PTY shell. Is we can do this. So we can do Python-C, and then still got to do it. Import PTY. PTY.spawn. So it's just executing a Python function, importing the PTY library, then PTY.spawn, which is a function, and then you put in your shell parameter here. So I'm actually going to do a bin bash shell instead. Is that right? Yes. And then as you can see, our shell has now changed from just this little dollar to full shell as you'd expect to if you were in front of your machine locally. So if everyone's done a different port, it should be easy for everyone to get some connections back. So we've now got an interactive session on this web app due to the local file inclusion vulnerability and due to the code injection vulnerability in the PHP Lite admin. So we want to elevate our privileges, and there's a lot of ways we can do it. We can look around for files. We have a persistent access now, but we don't know the password for this user. We just know that we have access. So what we want to do is we want to try and elevate privileges to root. So we can run a command such as sudo-l to see if we actually are in sudo, if you have sudo privs. So we can try that. And we can see that even though we don't have a full sudo access, we can actually use these two binaries and run these as root. Cheers. So we can run tar that runs as root with no password, and we can run zip that runs as root with no password. If there's no password wasn't set, then we'd still have to put the password in for www.data, but we don't know the password for it, and we can't change the password unless we have the old one. So this is a key piece here, because we can now run these commands as root via sudo for this user. Make sense?
Yeah.
So you can configure your etc sudoers file. So if you were to configure it, you can basically, there's configurations you can put in here. So if you want to automate something and you want like a specific function to run as root, then there's legitimate use for it. If you don't want to run your whole operating system as root, you can have it a user as sudo that can access specific functions as root without a password. So it's like common functionality, but it's in your /etc/sudoers.
By default, is there?
So default, no. These are just, this might be, someone might say that the web app is going to be constantly extracting data and it needs to be running as root so it can write to certain directories, for example, within this function. But we can actually then use this function, we can abuse it. So, I mean, there might be legitimate use, but from an attacking point of view, that's still a weakness that we can now abuse. So, like I said here, so you've got these two binaries that run as root, so tar and zip. So it might be that a developer's thought, okay, we need to run this all as root because the web app needs to do certain things with these zip folders or whatever.
I guess the point there is that, like, as an attacker, on a sort of a black box system, you didn't know a lot about the system up front. You would look for all sorts of things, including this, in order to elevate your reputation. And then, so this is something that you do occasionally.
Yeah. Because I mean, there's loads of ways we could look at like kernel versions. We can see, is there a kernel exploit for this?
Sticky bits.
Yeah, there's loads of stuff that we can look for, but this is quite an easy win to look for if they're in a sudo's file and if they have any binaries they can run as sudo that could be exploited. or abused. So these binaries run as root, so we can actually abuse their inbuilt functionality to provide us with a root shell. So using zip, there's actually a -tt switch in zip that we can specify another command to be run instead of the standard error checking function normally used. So when you zip something with -t, it does like an error checking at the end of it. It runs like an error checking binary. But if you specify -t and -tt, we can specify a different binary to be run instead. So this is a way, and because it's running as root, when it executes this, it will actually be running as root. So it'll give you a root bash shell back to the user. So a way to do this, first I would go to temp directory so we know we can write there. So touch, which creates a file, an empty file, but it just still gives us something to work with. And then we can use the command zip. Actually, it'll have to be sudo, remember, sudo zip. So blah.zip, which is the file we want to write to. Give it the file you want to put into it. Zip -t-tt. Sorry?
That is block.
Oh, yeah. And then bin bash. Not work. Sorry, I will try again quick. It's alright, I might have mistyped something. No? I literally copied that earlier. That's alright, we'll do it the other way instead. That's not working. 1 second. So, okay, so we've got our connection back again. Spawn. Unless something's changed in that sudo as file. I don't know why that didn't work, because I literally just did it before. Yeah. Oh, shit. It shouldn't matter, no. For God's sake, let me just get my shell back. 1 second. It shouldn't matter because because it's still executing, that's kind of a different error you get. Oh. I'm just going to copy these commands out so it works quickly.
Yeah, especially when you have a reverse shell. Sometimes when commands are going wrong, it will spit out all sorts of rubbish.
Yeah.
Irrelevant.
Spawn.
In theory, then need to do this.
Why is that not working?
Close on.
Okay. Right, so we're back to where we were. So sometimes I don't know why this isn't working, but it was earlier. But thankfully, there's another way we can do it. So we can do it with tar instead. So it could be that in this, wherever it is, when we do our sudo-l command, there could be multiple binaries we could use that we can exploit. And you'll find that a lot of these have functionality to get your shell after, to elevate to a root shell. So some of them you can do like an exclamation mark interactive, for example, and that will put you into a shell. So we can append that to another command, and that will drop you into a shell after. But we're going to do it with tar instead. So we're going to, same again, we're going to create a file. First go to temp directory. So our file is still there from when we failed before. But now we can run this sudo tar. It's basically the same thing again. You give it some special parameters. So you set the checkpoint as 1. Then when this checkpoint action, when it hits it, it's actually going to execute a bin bash shell instead. So it's just another way to add some switches in that are going to run as root. So if we copy this out again, because it's easier, we can copy that, and we can run it. Unless someone's changed this, because this was not how it was before. I don't know if someone has changed it, because it shouldn't ask for a password for these binaries. No, I think someone must have changed it, because it should be able to run these binaries without a password.
I mean, so when you're running tar, is it, which is it? Assuming that
It should be the same one. I mean, we can try it without. We can do. It's the issue with having a lot of people logged on. No.
Or if you just stand it, press stand it. You try it though.
Yeah.
I mean, I tried it before, so I don't know why someone has changed it, or something's changed in this etc sudoers file. Let me quickly do another thing. That's on the host. I don't know how to log into it from there. Okay, well, I mean, I don't know why it's not working for this, but this is how you would get it to elevate. Like I said, you could do it with either zip or with tar or any other binary that's actually included in that sudo-l file or sudo-l output. I'm really not sure why that doesn't work, because it should. So that's quite strange why it still prompts for a password, even though it's configured not to. But anyway, let's move on from there. So that's how it would work. We would then get a root shell once it works properly, and then that'll be it. So I don't know why that hasn't worked. I'm genuinely quite confused, because I did it 5 minutes before starting.
With these sorts of pen tests or hacks generally, like you're basically engineering an exploit, and so it's just like any sort of other engineering, where a lot of times you find yourself troubleshooting what the problem is, and yeah, often you'll find that it's gone right up to a certain point, or even that you've already got it working, and then suddenly it just stops working, and then you got to figure out why. This isn't uncommon, but
Yeah, this sort of thing happens all the time.
yeah.
So yeah.
Yeah, what that output's telling you is that you can sudo with those binaries, but you shouldn't need a password.
Which is why it's weird when you then run it and it prompts for a password.
It's asking for a password.
So I don't know why that's not working.
Something's going on.
There must, there's a configuration change somewhere.
The
Probably
point
works
being, I mean, that's the last step. Like,
Yeah,
where that's working, should we spend the time to work out why it isn't working? If we work through this, you have a root shell at that point.
Yeah.
You have admin access to that box.
Yeah.
Meaning you fund it completely. From there, you might try to pivot into other things it connects onto, as we've done in previous sessions, or scrape for credentials, and then use those credentials in an onward attack, things like that. I mean, sky's the limit. At that point, you have ultimate access, and so yeah, you just have a look at what possibilities are open to you at that point.
So yeah, so unfortunately it doesn't work. It did before, but for whatever reason, it's not at the moment. So that would be it. So like Sean said, you'd be greeted with that root shell, and that would be the end of it. If that was all you were going for, you could then, like you said, pivot and do other things. So the important bit is how you would actually mitigate the issues that have led to this state. So with the local file inclusion, if possible, you don't want to permit appending to file paths directly. You want to have these file paths hard-coded or selected from a limited hard-coded path. If you do need dynamic path creation of concatenation, you need to make sure you input validate. So only between A to Z and 0 to 9, no dots or slashes or null bytes, or anything that could be used potentially to traverse the file system. So going on from there, we found the dbadmin directory. So we need to lock down sensitive directories via IP or authentication. You shouldn't be able to be publicly accessible to access this sort of login page. Again, default admin credentials on that PHP service. Default creds should be changed prior to release. This happens all the time. People get hacked in the real world all the time with default creds. So it's a really common thing that is really easy to fix. Again, so we now found the outdated software, the PHP shell. So we need to patch that outdated software because there's a publicly written vulnerability for it. It needs patching, and it should be part of your regular patch checks that then get performed alongside patching rotors and deployments. So filtering out, so to stop reverse connections coming back, we should have stricter firewall rules on outbound connections. Network intrusion systems should be implemented to log these connections and potentially stop them as they go. And then finally, the sudo privesc. Ensure that even if an account needs sudo, it must be explicitly needed. So you want to rely on the principle of lowest privilege possible. And typically, www-data should not need sudo to function normally. And that is it. Unfortunately, sorry it didn't work. Something must have changed, but aside from that, the other issues are still there. So this local file inclusion that you can then call a vulnerable page generator from another vulnerable function as well is how you would chain it together. So as long as people understand that, then that's really the key piece. This piece. This. So this would be what I would assume it's doing is writing to standard out and standard in. It's probably what I'd assume it would be doing. Or so you have it'll execute an interactive bash shell, and this will be your standard in and standard out. You can actually read. So that's getting sent to, well, you have your socket, you open the socket, and then this executes this command and sends these standard out and standard into this socket. That makes sense?
It's just like raw socket.
Yeah.
Redirection
into your socket objects. But there's loads of ways. You don't have to do this in PHP. You could have done it in Python, or you could have done it in Bash or Perl or any other scripting language. There's a lot of ways you can do this.
In the first Security Champion session, we used
Python, yeah.
Yeah, so there are all sorts of reverse shell one-liners.
So there's like
you might be in a situation where a reverse shell is possible in a given language. One-liner doesn't work, but another will. Play with it.
So you can do it with any of these, like Bash. You can do it with Python,
yeah.
PHP, Ruby, Netcat if it's got an old version of Netcat, Java, anything else. So there's a lot of things. So because I chose PHP because I know it's running a PHP app. Python would probably work on literally every Linux server going. Perl, if it's an older system, you want to use Perl or Bash, for example. So there's a lot of ways we can we can use it to get that connection back. Obviously, you just got to change these respective variables.
Maybe when you can bootstrap from like up into creating a .NET sockets that would help chain these things together. Sometimes pretty easy to do.
Yeah. Or alternatively, what we could have done, another step, instead of putting our reverse shell in, we could have actually executed some code we could have generated, say, like a backdoor or like a Trojan, for example. We could have then generated that, and instead of putting this PHP code, we could have done like a wget, download the virus, and then run it, and then that would have ran that binary. And then you could have got a callback that way through that Trojan, as you would say. So there's a lot of ways we could have done it, but this is just the easiest, and you're not writing anything to disk, you're not writing any malware that could get flagged up by AV and get caught out. This is just like pure sockets using a language you know is already installed, so you're kind of guaranteed for it to work. But yeah, it's just really important you URL encode it as well, because otherwise it won't work. Because you're typing it into the URL, you need to make sure the URL the browser can understand it. So yeah, any questions?
You have like a session or like 1 minute like challenges that you can do.
Yeah, so we're going to put this public anyway, because it's built off AMI, so we can share the Amazon AMI. I could then, I could do a list of other things to look at, like some other apps to look at.
You like the practice?
Yeah, there's quite a lot of stuff out there. I mean, I could put a list together for everyone to look through. People find that interesting.
They're like what the awesome list in GitHub, for instance. Put that in there.
Yeah, and there's good things that aren't just like challenges. It's more like you'll actually learn it as well. So you'll learn the concepts and then you'll do the exercise at the end.
OWASP has some good, like fully featured training web apps with multiple challenges built in. They think there's all sorts of it, so right there.
So yeah, that's kind of it. If there's any questions, someone can answer this question, why it didn't work, that'd be great. So that's when you run it, that's to make sure your shell comes with root shell. Otherwise, you'll just get a normal shell back. So you have to specify that. So confused what doesn't work. No.
They're working on solving the JSON. So isn't that server where you're running this?
This is the web server.
Isn't that called MLJSON?
Yeah, it shouldn't matter. Yeah, don't know. It should work. Just doesn't work. I literally don't know, unless I reboot it and wait for the config changes to go through.
Just to answer that question on that able to resolve, I'm suggesting cat Etsy hooks name.
Well, that would just be MOJ7.
Yeah, exactly.
Yeah.
So
Same because that's what I changed it to.
I've seen that before, and to be honest, it never really mattered, so I never got to the root of it.
No, it doesn't matter.
Yeah, but you can see all sorts of random stuff. Coming up with a reverse shell. And you're just gonna roll with it.
Okay, you can also do root password now. Nice and secure. Yeah, so it should be in there to work. So you can see it here. So I'm not sure why it didn't work. It should have, but for whatever reason it didn't. But it doesn't matter.
Yeah.
The concept's there, and if there was other binaries in this, like Nmap or anything else, there's a lot of ways you can break out of them. So like simply, you can Google for like sort of like this might be on it. It depending on what it is, depending on what binary there is. Like you can change. Yeah, there's so much stuff on there. It's quite hard to say. It just depends what the binary is. Like if it's tail or if it's cat, or if it's mmap or nano or anything. There's inbuilt functions in there, and if it's running as root, you can break out of the main function and do something else. Yeah, nano. I can spell interactive. Like things like this. There's just a lot. Or Nmap, or like you could do like a bash -p does it as well. So this, if for example you had bash running in here, I could probably do it actually. Oh, I don't have nano in it, but yeah, I could always edit this and put bash in here. So when you run sudo bash, it will give you a bash shell straight away, or sudo bash -p. So there's a few things you can put in.
Is that not the default?
So no, it's not. Someone will have added this in for a specific function that can then be abused by something else. But they've already given this user sudo, so why they would do that, I don't know. But yeah, so it's just a misconfiguration that someone might not even think about being an issue, just because they want to automate something.
All right. Well, thanks everyone for joining us. I know this one was a bit more complex than previous ones have been. That said, it's representative of some things that we've seen on tests in the past, I'll say year. Not necessarily this complex a chain, but some of these vulnerabilities we've used together to blow open systems. And so it just gives you an idea of how an attacker might do it. We can't possibly show you every different possibility, permutation, but yeah, these vulnerabilities are realistic and can be used in real world attacks. So yeah, really appreciate your time. Hope you enjoyed, and we'll see you next time. Cheers.
Cool.